Okay, guys. So hopefully you did pretty well on your quizzes. Now we're going to talk about our last topic in the quadrilateral section, which is the trapezoids, or as we kind of say, the other quadrilateral. Now, this lesson is self-paced. That's why I have it on a YouTube video. That way you guys can slow it down, back it up, repeat it, whatever you need to do. So I'm going to go a little bit quickly through the lesson so that it's not too long. But remember, you can always back it up, stop it, pause it, replay it, however you want to do it throughout the lesson. Okay? So, trapezoids. Now, the one big difference between what we've been doing so far in trapezoids is that all of the parallelograms, one of the very first definitions is it has two pairs of opposite sides that are parallel. Well, trapezoid, they only get one pair of opposite sides that are parallel. All right? And what we have here is what most people think of when they're talking about a trapezoid, which is kind of the version of an isosceles trapezoid. But understand that no matter how it's oriented or which direction it's pointed or what shape it looks like, as long as it's a quadrilateral, which means it has four sides, and one of those pairs of sides is parallel, we still call it a trapezoid. Now, just like the parallelograms, trapezoids have their own set of properties. All right, and to understand the properties, the first thing you need to understand is the vocabulary. Well, there are different parts to the parallelogram. We have the bases, we have the legs, and we have the base angles. The bases are going to be the sides that are parallel. So, for example, in this figure, you have segment PA parallel to segment TR. So those two segments would be our bases. The legs are the two non-parallel sides. So in this figure, that would be segment TP and segment RA. Okay? So those are the two pairs that are not parallel. Those would be the legs. Your base angles are the angles that are created at the base. And the key thing to understand is there are always two pairs of base angles. Here we have our first base at the top. So we could say angle T and angle R is one pair of base angles. The other base is down here. So we could also say that angle P and angle A are the other pair of base angles. Okay? The other thing up here, though, something maybe ask yourself is, well, what about MN? Well, notice MN is in the middle. And we call this segment the midsegment. By definition, the midsegment is a segment that connects the midpoints of the legs. So, if this MN is the midsegment, that means it bisected both of these sides. And that also means that it has to be parallel to the bases. The midsegment is always parallel to the bases. We can calculate the length of the midsegment with the formula m equals 1/2 b1 plus b2. That means that the midsegment equals 1/2 the sum of the two bases. So I take one base and the other base, add their lengths together, cut that in half, that'll give me the length of the midsegment. So let's try some examples of this. If I look at the first one, the top one, I see I have a trapezoid. Right here it shows that the sides are parallel, right? And I have the midsegment in here, so I know midsegment equals 1/2 of b1 plus b2. And we know that addition is commutative, so it doesn't matter the order that we add the other two numbers in. So I can say the midsegment is 1/2 of 10 plus the 16. So that's 1/2 of 26, which gives me a mid-segment with the length of 13. Okay? And again, I'm going fairly quickly, so if you need to stop, review the problem, go through it a second time, do that. On the second one, they give me the mid-segment. Well, you still are going to use the same formula. Mid-segment equals 1/2 the sum of the bases. Except here, this time, we're going to put 17 in for the mid-segment. That's going to equal 1/2 of the x plus the 15. Now, first reaction usually here would be distributed. However, if I distribute it, I'm going to get 1/2 x and 15 halves, wouldn't I? And that's going to get really, really messy. Always remember, to get rid of a fraction, I can multiply by its reciprocal. Well, the reciprocal of 1/2 is 2. And as long as I do it to both sides of the equation, I'm good to go. So this 2 will cancel this half. I'm left with x plus 15. 2 times the 17 is going to give me 34. Now I can subtract the 15 over, and I get x is 19. Okay? So, if you want, at this time, hit pause, try these couple problems, and then hit play and see if you get them right. All right, so, again, mid-segment is 1/2 b1 plus b2. Here, that gives me the mid-segment, so that goes in for m. And just like we did on the last one, to get rid of this half, I'm going to multiply by 2. Do it to both sides. Well, 10.5 times 2 gives me 21. Equals the x plus 12. Subtract and I get x equals 9. Now, if I look at the second example, here I don't have anything to do with the mid-segments. Sorry, I got interrupted by a knocking. So when I look at this one, now this one doesn't deal with the mid-segment. This is actually talking about the angles. Well, remember, just like in the parallelogram, if I extend out the parallel sides, and I look at these two angles here, I have the x and I have the 62. These are corresponding angles. Nope, I lied. These are consecutive angles. And we know that consecutive angles do what? Add up to 180. So my x plus my 62 equals 180. So my x is 118 degrees. All right. Now, could I use the x with the 90? Not this time. Remember, this is the big difference between a trapezoid and a parallelogram. Parallelograms, both pairs of opposite sides are parallel. So I have multiple ways of doing consecutive interior angles. However, when I have a trapezoid, I only have one pair of parallel sides. So I'm going to have a set of consecutive angles like I did here, and I would also have a set of consecutive on this side. But it doesn't go the other way. Okay? Now, that's the most you can do with a plain trapezoid. You can find the length of its mid-segment, and you can do consecutive interior angles. However, when you have an isosceles trapezoid, now this will take on extra properties. Okay? The three extra things that happen in an isosceles is that the legs are congruent, just like in an isosceles triangle. You have the two congruent legs and the base is separate. Here, the two legs are congruent. All right, so GM is going to be congruent to EO. Also, now there's a relationship between the base angles. Here, each pair of base angles are going to be congruent. So, angle MGE is congruent to angle OEG. And the same thing is going to occur at the other base. Angle GMO is going to be congruent to angle ELM. All right, and then the third thing that gets to happen is your diagonals are congruent. So now I can say that the length of GO is congruent to the length of EM. The length of GO is going to be congruent to the length of EM. Okay? So in a regular trapezoid, all you have is the length of the median, and that you can do consecutive interiors. All right? In an isosceles, those two still apply. However, I can also add in these three properties. That the legs are congruent, the base angles are congruent, and the diagonals are congruent. So, if I look at an example like this, when I want to solve for the length of x and y, I have to look. This is the angle that's given. So I'm going to base everything off of this angle. When I want to solve for x, I look. Remember, you still basically only have two options, either consecutive or opposite. These are consecutive interior angles, formed by the parallel sides. So they have to add up to 180. That gives me x equals 134 degrees. Now when I solve for y, this is where you have to be careful. Because a lot of times kids want to say, oh, y and 46 are opposite angles, so y is 46. However, this isn't a parallelogram. So that property doesn't hold true. Instead, I can say, though, that these are base angles. And it shows me that this is an isosceles trapezoid. So we know base angles are congruent. So if x is 134, then y is 134 degrees as well. Okay? And then I'll look at this image. Now, if this one's not on your paper, hit pause and draw it before we continue on. But if you have this on your paper, or if you've drawn it down now, here again, we're dealing with the diagonals. So you think back to the three properties that we had for an isosceles, because it shows me that this is an isosceles trapezoid. We know that the diagonals are congruent. So I can take this diagonal here, which again, it's this portion plus this portion. So 3x minus 2 plus 2x. That's going to equal this diagonal, which is this portion plus this portion. Do a little algebra. This gives me 5x minus 2 equals 7x minus 4. I'm going to subtract the 5x over. That gives me 2x on the right. I'm going to add the 4 over. That's going to be positive 2 on the left. Divide by 2. And I get x equals 1. Okay? So, if you want, press pause. Try these two problems based on everything that we've done today and see if you get them right. So, when I look at the first one, I'm solving for x. I see I have a midsegment. Anytime you see you have a midsegment, write down the midsegment formula. You have to memorize this formula. This is not given to you on your SOL. So you have to memorize it. So plug in all the parts. Here's the mid-segment. 30 equals 1/2 of base 1 and base 2 added together. Okay? Just like before, multiply by 2 to get rid of the 1/2. That gives me 60. Now I can clean this up. This -5 and this +5 are going to cancel each other out. 9x plus the 3x gives me 12x. Divide both sides by 12, I get x is 5. Okay? Now, on the second one, I'm dealing with the angles. So again, remember, it shows me it's an isosceles. So I can remember consecutive angles add to 180, base angles are congruent. So I see that these two x terms are base angles. So I can take the 2x plus 42 and set it equal to the 6x minus 2. Base angles are congruent. Subtract the 2x over, that gives me 4x. Add the 2 over, that gives me 44. That gives me x is 11. Okay? Now, to find y, well remember this is a trapezoid, so opposite angles do nothing. But these consecutive have to add up to 180. And now that I know what x is, well I can say 2 times 11 plus 42, that's 64 degrees, isn't it? So now I can say the 3y plus 5 plus the 64 has to equal 180. Well, these two combine to give you 69. And if I subtract that, I get 111. Divide by 3, and I get y equals 37. All right? All right. And I can't remember if I printed these two on your sheet. If I did, we'll talk about those in class next week, okay? Because these lead into solving quadratics and systems, and I'd rather do that with you than on a video. So, there's your lesson on trapezoids. Now that you've finished your lesson, you get two options. A, you can work on your homework. I believe you go get it from the sub. Or B, you can work on your IXLs, okay? Which those should be on Edmodo. All right? Have a great weekend, and I will see you guys next week.